What's poppin', dogs? Mr. Allen here. We got ourselves a doozy of a problem here. We want to write the equation of a quadratic function that passes through negative 114, 25, and 314. We don't have a vertex. We don't have any x-intercepts. We don't have a y-intercept. We just got three random points that some kind of a parabola, or maybe it's upside down, maybe it's negative, I don't even know, is going to pass through those three. So what the heck are we going to do? First off, I'm going to write down my standard, aka general form of a quadratic function here. So we got ourselves ax squared plus bx plus c. I don't know a, b, or c, but I need to figure those out. In my final equation, it's going to be y equals some number, x squared, some number, x, and some number. All right? That's what our end goal is. Now I got 3 points that I can use for my x and my y, my x and my y, my x and my y. I could set up 3 separate equations and solve for those missing variables. Because if I have 3 equations, I can solve for 3 variables. If I have 2 equations, I can solve for 2 variables, right? Systems of equations. So let's get after it. Let's get the first one going here. We got negative 1, comma 14. So I'm going to set this one up with green. So I'm going to have 14 in for my y and negative 1 in for my x. So I will have 14 equals, and then I'll have a times negative 1 squared plus b times negative 1 plus c. And I'm going to clean this up a little bit. I'm going to have 14 equals, that's going to be a minus b, we'll do minus, whoop, b, nice save, nice save. There we go. Next one, I'm going to go in blue. We got 2, 5. So I'm going to throw in 5 for y, so we get 5 equals, and then a, and we got 2 squared plus, and then we have b times 2 plus c. All right, we'll clean it up a little bit. We got 5 equals, 2 squared is 4, so we're going to have 4a plus 2b plus c. Woo-hoo-hoo-hoo. Man, we are cruising. So next one, we're going to do an orange. 14 goes in for y. And I've got, let's see here, a parentheses 3 squared so now I have 3 separate equations. 1, 2, 3. I'm going to take 2 of them. It doesn't matter which 2 we pick, but we got to put 2 of them together, and we're going to try to eliminate one of my variables. The easiest one to eliminate right now is going to be c. So I'm going to take that green one up top there. I'm going to have 14 equals a minus b plus c. So we're going to have 14 equals a minus b plus c. And then I'm going to take my blue one there, and I'm going to multiply through by a negative so that I get a negative c and it cancels out, right? Elimination method. So I'm going to have 5 equals, sorry, negative 5 equals, almost forgot to multiply through with that negative. Negative 4a minus 2b minus c. Now when I add these 2 together, I'm going to swap markers here. We're going to go in pink for this guy here because I got a brand new equation. It's none of these. I'm going to have, let's see here, 9 equals negative 3a minus 3b, and those c's are gone as we planned. So this is one equation I can use here in just a little bit. Now I got to use 2 other ones. We'll use that bottom orange one there. And why don't I still use the blue one? All right, because I already multiplied through by a negative once. I've already done that work. Now I don't make a mistake on somewhere else, right? And honestly, if I made a mistake on that blue one there, I'm already like, I'm done with this one, right? I already screwed it up. So anywho, back to the orange. We got 14 equals 9a plus 3b plus c. And then the blue one is going to come in there at negative 5 equals negative 4a minus 2b minus c. And now, once again, let's get that resulting equation here when I do elimination. We've got 9 equals, and then we have 5a plus b. My c's are gone. I got 2 equations, 2 variables. I do believe I can set up a system of equations of only 2 equations here. So let's write those 2 together. I've got, well, we got this one already written here, so we'll save some space here, and I'll do 9 equals negative 3a minus 3b. This right here is a system of 2 equations. That is super duper dope. Now I can do elimination. Do I have anything I can eliminate? No. But if I multiply this top one here by a 3, that's going to be positive 3b and negative 3b. All right, now this is not official notation here where you put parentheses around an entire equation. Really, I should write that 3 here and over here. So Keep that on the hush-hush, on the DL. Don't tell any mathematicians or I might end up in math jail, but I'm doing it right now because, hey, I didn't feel like writing that much. And I've already talked about it enough that I could have written it. Whatever. I'm moving on. So I've got 27 equals 15a plus 3b, and then that guy stays the same. I have 9 equals negative 3a minus 3b. B's are going to cancel. Woo! I got 36 equals, we have 12a, so that means that a is going to equal 3. Oh, yeah. I got one of them. How am I going to get the others? Well, if I got one, I got some equations here that only involve a's and b's, right? That one right there just has b chilling by itself. Could I substitute that in? Heck yeah, I can. So I'm going to have 9 equals 5 times 3 plus b. So that's 15 right there. I'm going to get negative 6 equals b. Woo! That's dope. All right. So I got A, I got B. I just need C, dogs. I just need C. Well, if I got A and I've got B, I got a whole bunch of equations here that have A's, B's, and C's. Look at this first one up here, that green one. C's chilling all by itself. It just wants to be solved, right? Okay, let's substitute it in there. So we got 14. Let's do this in a different color so it doesn't get mixed up in there. How about I go with this guy right here? Okay. So we got 14 equals, and then for A I had 3 minus negative 6 plus C. So I've got 14 equals, and then we got 3 plus 6, that's 9, plus C. Subtract that, I get 5 for C. I now have A, B, and we have C. Woo! Are we done? No. I got to write my final answer, dogs. Don't do all this work and not write your final answer. All right, we're going to do that in this guy right here. We got y equals. We'll just write it right up by our original one. Equals. My A is 3, so I got 3x squared. My B is negative 6, so I get minus 6x. And my C is positive 5. I get plus 5. There is our final answer in standard, aka general form, from 3 points, no x-intercepts, no vertex, no y-intercept. They just threw us to the mathematical streets and said, hey man, figure it out. And we did. That's dope.